Okay, so concentration is where we express the amount of a chemical that's in the solution. And it's important because we actually need to know how much of a chemical, which we typically call a solute, right? The solute is the substance being dissolved. In any volume of solution, because we might use that to react it with something else. And there are a lot of different units for concentration. To give you a couple of examples, ppm is parts per million. We will be focusing on something called molarity, which is a capital M. And this is the number of moles of the chemical that we're looking at in a liter of solution. There is a very useful triangle called the molarity triangle. It looks like this. You're going to have a capital M in the lower left-hand corner. You'll have moles on the top, and then liters on the bottom right, okay? A couple of things you should know for molarity calculations. You learned in section 3.2 how to convert grams into moles by dividing by the molar mass. You also learned how to convert moles into grams by multiplying by the molar mass. Okay, so grams could play a role in molarity calculations. You also learned back in chapter 1 that if you have 123 milliliters, that's the same thing as 0.123 liters. So this is a one-step metric conversion, but you don't have to show it to me. I'm okay with you just moving the decimal over. Okay? Now, since molarity is moles divided by liters, the fraction unit can be used to convert between moles and liters depending upon our needs. So just to give you an example, down here, it says 3 capital M HCN. What that means is we have 3 molar HCN. So in 1 liter of solution, I have 3 moles of HCN, and I can write that as a fraction depending upon what my needs are. Sorry, I just got my elbow on the screen. Okay, and I'm going to show you how to use this as we go into the next page. So let's take a look at the next page. And there are a couple of sample problems over here. I'm just going to give you the brief overview of these sample problems. This would be good to do for practice for the quiz on molarity for next class. So this first sample problem gives you the molarity of seawater. That means the amount of salt that is in the water. And they want to know how many moles of salt are in a toy bucket with 435 milliliters of seawater. Okay, so if we are using the molarity triangle, and you're solving for moles, you cover up moles, and it says to take molarity times liters, right? So that's pretty straightforward. You have milliliters here, so you would just move the decimal over, okay? Okay, another sample problem would be down here, where they're asking you to solve for volume of 3 molar HCl, and they want to have 0.25 moles of HCl. So if you're solving for volume, you're solving for the liters, okay? Again, if you're looking at the molarity triangle, you're going to cover up liters because that's what you're solving for. And when you cover up liters, it says you're going to have moles divided by molarity. Does that make sense? Your book is showing you how to cancel units to get it. You don't have to do that with me if you're using the molarity triangle. Okay? Okay, on the next page, what I want you to do with the molarity triangle as a guide, I want you to do these 3 practice problems. Let's see what you come up with. equation did you get for number 1? Like that?
Yeah.
Okay. And then what did you get for your answer?
4.8.
Perfect. For number 1, since you're solving for moles, if you cover up moles in the molarity triangle, it says to take molarity times liters. Okay, so that's what we did. 2.5 molarity here times 0.72 liters. Round your answer off to 2 significant figures, so that's why I wrote 1.8. Does that make sense? Yeah? Okay. Do the same thing with number 2. Just watch your units on number 2. What did you convert 500 milliliters to in liters? Which way did you move the decimal? To the left, how many? 3. So you got 0.5. Okay. Okay. How many significant figures are you rounding number 2 off to? 3. So I got 0.0770 because trailing zeros count, but leading zeros do not. Yeah? Okay. For number 3, if you're solving for liters, what equation would you use? Moles divided by molarity. Okay, so this is 3 moles divided by 0.60 molarity. And you're going to get 5.0 liters. Okay, so memorize the molarity triangle. I'll give you 1 molarity problem on the test. Okay. Can I go on? Okay. I have 2 more things to talk about. One of them is how to make a solution. This is what you're going to do a lab on next time. Okay. So making a solution is a skill that you have in chemistry. And if you know the concentration of the solution, it's called a standard solution. Okay? This paragraph explains how to make a 1 molar sodium chloride solution. Sodium chloride is table salt. Okay? So I will probably ask you on the test to explain to me how to make some molarity of a solution. And the way that you do that is you calculate the mass that you have to measure out of the salt. Okay, and I'll show you how to do that. So this says measure out 58.44 grams of NaCl and then add water up to 1 liter. The reason why it says add water up to is because typically when you first dissolve that salt, you want to add a little bit of water to dissolve it because it will expand. So if you add all the water, like up to a liter, like initially without dissolving it, it will go beyond that 1 liter mark. Okay, so here it says that the solute, which is the salt, will displace a small amount of water. So that's why you want to dissolve the salt in a small amount of water first. Then you can go and add the water up to whatever volume you need, okay? What I would do if I were you to get ready for this kind of a question on a test is I would do this sample problem here because it asks you to describe how to prepare a solution from a solid, and that's exactly what I'm going to do on the test, okay? Okay, so let's take a look at the next page at practice problem number 1. We're only going to do practice problem number 1, okay? So practice problem number 1 says, describe how to prepare 500 milliliters of 1.5 molar calcium chloride from calcium chloride solid. So we are going to be measuring out a certain mass of that solid, and then we'll dissolve it in water, okay? So what you need to do is calculate the mass of CaCl2 needed. How do we do that? If you take a look at the molarity triangle, we need to calculate moles so that we can convert moles into grams, okay? So that means moles equals molarity times liters. So this is 1.5 times, move the decimal 3 places to the left, 0.5 liters. Oh, I think I already have this written down. Yeah, I do. This is 0.75 moles of calcium chloride, okay? We have to convert moles to grams by multiplying by the molar mass of calcium chloride from the periodic table. Okay, so the number that goes here is the molar mass. Calcium is 40.08, chlorine is 35.45. Okay, so your molar mass is 110.98. You're going to get 83 grams of calcium chloride. I'm crossing out number 2 because we're not doing it. I'm going to use this space to write the answer. So what you're going to do is you're going to say measure out 83 grams of CaCl2. Put it in a 500 milliliter volumetric flask. Volumetric flasks are these containers that have kind of a ball shape on the bottom and then a long, narrow neck, and then they have a line, and that line, if this is a 500 milliliter volumetric flask, that line represents 500 mils. So that's what we would fill the water up to. So you would dissolve the CaCl2 in a small amount of water, then fill up to the 500 milliliter mark. That's it, done. Okay, so this is what you will actually do with a volumetric flask and sodium chloride next time. Okay, so on Tuesday.